Hello friends, in this video we are going to talk about another source of power which is used for generation of the microwave signal, that is nothing but the traveling wave tube. Radar is basically stands for radio detection and ranging equipment, and it is used for detecting and tracking the location of the object or location of the target. So for this purpose we require to provide power to the radar. So the function of transmitter is to transmit the signal towards the target. The different types of transmitters used in the radar based on the application in which the radar is going to be used. If the radar is used in the remote sensing application, then it requires a different types of transmitter. If it is used in case of military application, then the requirement of the transmitter is different. So there is no universal transmitter that can be used for all the application, as what happened in case of receiver. Most of the receiver uses super heterodyne receiver as it fulfills the requirement of all the application. But this is not the condition in case of transmitter. Depending upon the requirement of the application, requirement of the system and requirement of the user. Also the various parameters like range, azimuth angle, then the distance covered by the signal and other environmental factors changes the need of transmitter. Therefore, these parameters are basically used to determine which type of transmitter or which type of power source are required to be used in the radar system. So, the two basic types of power source that can be used in the radar system are nothing but the self-oscillating power source and oscillator with built-in amplifier. In order to generate the microwave signal, we can use the tube power sources or the semiconducting devices. The tube power sources include klystron amplifier, specifically the two-cavity klystron. Then second is traveling wave tube amplifier, and the third is nothing but crossfield amplifier. The semiconducting devices which can be used for the generation of power are nothing but the gun diode and impact ionization avalanche transit time diode. So now in this topic we are going to specifically discuss about the traveling wave tube amplifier, and along with it we are also going to discuss the following topics, and the topics are use of slow wave structure and continuous wave operation, TWT helix structure. Then we also have a look of the block diagram of helix traveling wave tube amplifier. Then we will also discuss the TWT amplification process, and at the end we will find out various applications of TWT, and at the end of the topic we'll discuss some MCQs so that we can understand the topic properly. So let's begin with the TWT, that is traveling wave tube. The traveling wave tube is also called as TWT, which is considered as one of the powerful source for generation of the microwave signal. TWT is basically the amplifier which uses interaction between the electron beam and the traveling wave along its length. It is basically an O-type parallel filled linear beam, and it is different from the crystalline amplifier. In this case, or in this type, in traveling wave tube, the interaction between the electron and the electric field takes place over the entire length of the tube rather than taking only place at the cavity. In case of klystron amplifier, the interaction takes place only at the cavity, but this not happen in the traveling wave tube. In this case, the interaction takes place along the entire length of the tube. The traveling wave tube is basically a resonating device which provides a wider bandwidth as compared to the crystalline amplifier. It is available in different forms. It is available in single helix structure, it is available in double or folded helix structure, it is available in ring bar structure. But mostly or the more commonly, the single helix structure is used for the construction of traveling wave tube. The single helix structure is made up of a material like tungsten, and in this case the phase velocity is given by the phase velocity is given by Vp, that is nothing but phase velocity. So Vp is equals to Cp divided by square root of P square plus pi d square, where P is the helix pitch, d is the diameter of the helix, and Vp is the phase velocity. The traveling wave tube uses the slow wave structure. As its name indicates, the slow wave structure is basically used to reduce the velocity of the electron or velocity of the beam so that we can have a large value of gain at the output. So the figure shows the helical structure in which it uses slow wave structure. So here P is the helix pitch, L is the length of the helix, D is the diameter of the helix, and on the basis of these parameters we can define the phase velocity, and it is in terms of meter per second. So phase velocity having unit of meter per second, the pitch is in the range of meter, and diameter is also in range of meter. So now let's see the construction of traveling wave tube. Now, from the figure, we will come to know that the TWT or the traveling wave tube consists of electron gun and the slow wave helix. The electron gun is basically used to emit the electrons by heating it. So when the electrons ejects the electron beam is get directed by using a magnetic field. Now let's have a look of the construction of traveling wave tube. So from the diagram, we will come to know that the traveling wave tube consists of electron gun and helix slow wave structure. In this case, the electron beam is controlled or electron beam is focused by using a magnetic field. Now, the helix is nothing but a thin conducting wire which is in the helical form. The cathode is used for transmitting the signal, and the signal which is to be amplified is applied to the cathode which is nearer to the one end of the helix, and the amplified signal is available at the output, that is at the other end of the helix, which is nearer to the collector. So now here, when the electrons are get emitted by using the electron guns, the electron travel and focused by the magnetic field. The electron travels over the entire length of the tube. When electron enters into the field or when electron enters into the cavity, the interaction between the electron beam and the electric field takes place. And because of this interaction, the electron beam transfers its energy to the traveling wave. Therefore, the signal which is available at the output, that means at the other end of the helical structure or at the collector, having high amplitude or high gain. Now, in this case, the one end of the helix is made positive with respect to cathode and other end of the helix is made positive with respect to collector. Because of that, the electron beam is get attracted towards the collector. When the signal received at the end of the helix or at the end of the collector, it is having high amplitude. So that is how the amplification takes place. The traveling wave tube also uses the principle of velocity modulation, and it also uses a process of bunching. So because of that, the transfer of energy takes place between the electron and traveling waves. So when the electron transfer their energy to the traveling wave as they passes through the cavity, then because of the velocity modulation and the bunching process, the signal appears at the other end of the helix or the signal appears at the collector having large amplitude and large gain. So the gain obtained at the output of the traveling wave tube is given by So gain obtained at the output of the traveling wave tube is given by a formula gain, and it is in terms of dB. So gain in dB is equals to 47.3 FL3 divided by 2 pi V0 into square root of IK upon 4V minus 9.54, where F is the RF frequency in Hertz, V0 is the velocity, that is specifically the electron velocity, and its value is given as 0.593 into 106 volt into 1 by 2. Now here I is the current, K is the helix impedance, and I is the current, and V is the applied voltage or applied signal which is to be amplified. So basically the traveling wave tube provides the low noise signal at the microwave frequency, and therefore they are used in applications like pulse radar, they are used in the tracking radar, they are used in the application where low noise requirement is the major requirement of the application. So in this way, we can say that the traveling wave tube consists of the interaction between the electron beam and traveling wave along its length, and because of that, it get differs from the crystallon or two cavity klystron amplifier. In case of two cavity klystron amplifier, the interaction takes place only at the cavity. That is, there are two types of cavity: collector cavity and buncher cavity. So interaction takes place in these two cavity only. But the principle of operation is remains same, that the traveling wave tube also uses velocity modulation and also uses a bunching process. The traveling wave tube amplifiers are used in CW radar, that is continuous wave radar, or airborne radars. So now let's move to the MCQ part. The first question is, the slow wave structure part used in the traveling wave tube amplifier. Options are: cause the interaction operation between electron beam and microwave signal continuously. Option B is causes the interaction operation between electron beam and microwave signal at the cavity gap. And option C is used to attenuate the microwave signal. And option D is used to filter the electron beam. And we can say the slow wave structure which is used in the TWT is basically to reduce the speed of the electron beam so that the interaction can be takes place between the electron beam and traveling wave. So here we can say option A is considered as the right option. It causes interaction operation between the electron beam and microwave signal continuously as the speed of electron is get reduced so that it is possible to take the interaction between the electron beam and the signals which are continuously travel through the helical structure. Now let's move to the second question. And the question is, the term traveling wave stands for, options are standing wave ratio formed in the devices. Option B is the propagating microwave signal axially through slow wave structure interacting via electron beam. Option C is interaction at the cavity gap, and option D is none of the above. So we can say the traveling wave term is basically stands for option number B, that is the propagating microwave signal axially through slow wave structure interacting via electron beam. So this is what about the traveling wave tube amplifier, which is also used as one of the powerful source of generating microwave signal in the application like continuous radar or airborne radars. So we can use it to provide high gain at the output, or the signal will be available at the output with a large amplification. So I hope you understand the topic of traveling wave tube. So thank you very much for watching this video. Stay tuned to Ekeeda. Subscribe Ekeeda.